Good afternoon, everybody, and welcome to today's Conair Education Series webinar. The topic of this discussion is Fundamentals of Drying and Choosing a System. My name is Chad Stover, and I'm the Technical Marketing Manager at Conair, and I will be your host. This afternoon, we have AJ Zampanini presenting. It's my pleasure to introduce AJ to you. AJ is the Drying Product Manager for Conair. He started at Conair in the PET packaging group, and then advanced to the role of regional manager, where he managed a group of sales representatives. Now, as drying product manager, he is responsible for the drying product line and product innovations. AJ graduated from Penn State University in 2010 with a degree in mechanical engineering technology and a minor in technical sales. Prior to coming to Conair, AJ was a former customer, where he was responsible for plant and capital improvement projects. His on-the-job knowledge of systems and processing, along with his excellent education, have served as huge assets in understanding pain points and assisting customers solve problems. Recently, AJ has focused on several key product improvements and developments that make equipment more easy to use and technologically advanced. Feel free to ask questions anytime during this presentation. Simply use the Q&A panel on the right-hand side of your screen and type in your question. We will attempt to answer as many questions as possible following the presentation. It now gives me great pleasure to turn the program over to AJ.
Hi, everyone. Yeah, and like Chad said, thank you very much for dialing in. We appreciate it. Again, we'll go over the 4 fundamentals of drying and how to choose the right system. These are always a little difficult to put together, these presentations, because we get a big mixed bag, right? We get some people who maybe have never had to dry resins in the past and other people who have been doing it throughout their career. My hope is that this is put together in such a way that everybody leaves here with some type of takeaway that they can use in their daily jobs and responsibilities. So just to recap what Chad said, yes, I worked here as a regional sales manager. I graduated from Penn State Barron. More importantly, probably the most important bullet here is that I was a former customer and user. Of all the things I got to do as a plant project engineer, purchasing capital equipment, material handling was what I gravitated towards and is why I work here at Conair. If we move into the agenda here, just so everybody understands what we'll cover. 4 fundamentals of drying, understanding dew point, material moisture content and how that can actually impact your drying system, and choosing a system. So we won't necessarily get into sizing systems, but choosing what system is right for you. They are not one size fits all, and what works for one molder might not be a great solution for another molder. So we'll go through some pluses, minuses, tips and tricks, things to look out for. Just as a recap, so we're all starting, kind of on the same page. What you see over here on the right is about a 1,000-pound-an-hour Conair D-Series dryer. Color touchscreen, desiccant, blowers, everything is housed inside of this cabinet. What happens then is this dryer gets coupled to a drying hopper where the pellets get filled up into, and then that is how the drying system works. So we have 3 components here. We've got a process loop. So we take air, we pass it over desiccant, reduce the dew point, we heat it to the drying temperature, we pass that air through the hopper filled with pellets. The moist air will return back, get filtered, in some cases passes over an aftercooler, and then back through the blower. If it's a good dryer design, this is done closed loop, which means we're only taking out the moisture that we gain from the material. The second system is the regeneration system. So if our desiccant, if we look at it like a sponge that keeps absorbing water, this regeneration loop is equivalent to us wringing out that sponge. Now, Conair dryer works a little bit different than most dryers. We use a continuously rotating desiccant wheel, so we don't have any clay binder or desiccant beads, and we can hold a steady dew point. So this wheel will rotate, which means we always have a fresh face of desiccant to dehumidify our air. So this works as a continuous process. That, I think, is, let's call it drying 101 in a nutshell. This is what a dryer looks like internally. That is how it operates. Now let's get into some of the physics behind how the drying process works. First and foremost, why do we even have to dry? So a couple main reasons are going to be clarity, cosmetics, or strength. So if we're trying to make a clear part, a lens, a headlight, something that we want to be clear, drying is going to get you there. Improperly dried material can show up as splay or surface finish issues, but more often than not, will show up as cloudiness in your part. So if you mold today, you don't dry, or you're not drying well, you probably see cloudy parts. Cosmetics is another one. So let's say your part is not clear. You can still see some surface finish issues. Like a lot of times it's called splay. We can see pockets or voids in our parts, and that's all due to moisture in the material. And the last one is strength. So a lot of times these go hand in hand. Sometimes you'll see a cosmetic issue, so you know you have a strength issue. But it is possible to mold a part that looks okay, but has reduced strength properties because the material was not dried. Improperly dried material can degrade the capabilities. Good example, PET water bottles. They're very strong. You can drop them out of your car. They don't typically burst or break. That's because that material has to be dried, and if it's dried properly, it's turned into a bottle, filled up, and makes it all the way to your house without leaking. What needs to be dried? Two different categories here, non-hygroscopic and hygroscopic. I don't make up the names, I just talk about them. So non-hygroscopic materials, they do not have an attraction to moisture. They can pick up surface moisture, so consider it like condensation on the glass in the summer, surface moisture, right? Pretty easy to remove this. It's just like a single pass hot air dryer. So if you think about your hair dryer at home or your wife's hair dryer at home, it just makes air, it heats it up, and it blows it across the material. That's what a single pass hot air dryer is. Non-hygroscopic materials are going to be things like polyethylene, polypropylene, PVC. Those will all fall into this category. The way I like to look at it is, let's call it like a raincoat. You put on a raincoat, you go out in a rainstorm, you come inside. Most of that water is going to wick off the raincoat pretty easily, and when you take it off, everything underneath is dry. Hygroscopic materials, on the other hand, do have a strong affinity for moisture, which means they're actually polar, like little magnets, and they want to absorb that moisture in at the molecular level. So how much moisture and how fast does it gain this moisture depends on the type of material, depends on the ambient conditions, and depends on the amount of time that material is exposed. So if you have a really hot, humid environment, you're probably going to gain a lot more moisture a lot faster than if you had a very dry environment. That'll come into play later here in our presentation. These hygroscopic materials, polycarbonates, nylons, PETs, huge list of hygroscopic materials. They typically require heating, just like our single pass hot air dryer, but also dehumidifying, some type of desiccant system to properly dry these down to their moisture levels. So important to note the differences here. Most of this is going to be tailored towards a desiccant drying system, but there is a difference. So here it is, the four fundamentals of drying, right? We've got temperature, time, airflow, and dew point. So if you're someone who hasn't dried before, we'll talk about how these impact your process. If you're someone who does dry, this is a good way to compare dryers side by side from different vendors. If you have drying equipment, I guarantee if you have a problem, it's because of one of these four things. So learning about these could be a great way to troubleshoot the systems you already have. So our first fundamental is temperature, heat. So temperature is the driving force in drying. I consider it like the gas pedal. Without the gas pedal, you're not going anywhere. Heat reduces those attractions between the water molecules and the polymer chains. Also, hot air likes to hold more water. So if we think about it like bailing out a boat, we're going to want to bail out our boat with a 5-gallon bucket, not a Campbell soup can. So heating up that air gives us a bigger bucket to work with. If we don't properly heat the air, and the temperature to dry these materials usually comes from the material spec sheet from your material supplier. So we'll specify the temperature. If we don't give it enough heat, we'll get insufficient drying. If we're targeting a certain moisture content, we may not make it there. Or in order to make it there, it may take us longer. However, if the temperature is too high, you could get agglomeration, which is just a fancy way of saying material likes to stick together. In really bad cases, you could actually fuse that entire hopper of pellets, and you'll have to get in there with saws and chisels and try to hammer it out. So very important not to over-temp the material. In addition, you can get yellowing or discoloring of the material. So if you're trying to make a virgin or white part, if you over-dry or if you thermally damage this material, what you'll find is discoloration or just degradation. You can actually make the material properties more brittle or change some of the properties that you're looking for. Up here on the right, I got a pro tip. It says, do not increase the drying temperature to reduce the time. This can work, Some materials are a little bit more forgiving than others. What we find a lot is that with certain materials, it can get very wet, nylon being one of those. So in order to decrease the drying time, what people do will increase the drying temperature. The moment you increase that drying temperature, although you may dry faster, you're setting yourself up for thermally damaging that material, and it could only take a matter of hours to do that. So I would say make sure that you're drying at the right temperature so you don't cause yourself issues that maybe you may not be aware of. Airflow. This is our second fundamental of drying. This is the medium that transfers energy to the pellet. So if you're new to drying, we're not drying this material like in an oven, like baking a cake. What we're doing is we're passing air over a heater, sometimes electric, sometimes gas. It heats up that air, and then we pass it over the plastic pellets. That's what heats it up. So if we don't have enough air, we won't get proper heating of that pellet. In addition, this airflow is the way that we get moisture out of the drying hopper. So sometimes out of the drying hopper in the case of a hot air dryer, or back to our dryer to be re-dehumidified by our desiccant system. And the last bullet here, which we'll come back to, says typical sizing is about 1/2 CFM per pound per hour. That's how much airflow you need to dry plastics. Some plastics can dry with less, some need a little bit more. But at the end of the day, that is our good average number. If we don't have enough airflow, we'll get insufficient heating or uneven heating in that drying hopper. If we get too much airflow, as you can see here on the right, a lot of issues. Potential fluidization. So if you have a sight glass on your hopper, you can look at it and you start to see pellets almost look like popcorn in a popcorn machine. That's the start of fluidization, which could cause you issues down the line like interrupted mass flow. We could get carryover of plastic pellets. So if it's really high, we can actually blow some of our lighter pellets out of the drying hopper into filters or cyclones or things outside, so that would be a problem. If you have a mix of materials, so let's say virgin plastic pellets and light regrind, over time you can actually separate those two in a drying hopper if you have too much airflow and bad air diffusion. Conveying issues, sometimes you can plan around these, but if you pressurize this hopper too much, you can cause yourself some conveying issues, blowing material out the bottom of the hopper, holding vacuum receiver flaps shut. Those are all potential issues. But a really big one, and it's pretty easy to note from a math standpoint, is wasted energy. If we use twice as much air, we will use twice as much energy. It's a certainty, it's a calculated value. Same way, if we use half the amount of energy, we'll use half the amount of energy. So we don't want to go too low because we'll get insufficient heating. But if we go too high, we get all these issues, plus it's costing us money. So let's take a look at what that means. I'll highlight that again. Typical sizing is about 1/2 CFM per pound per hour, and that's maybe a controversial statement. So if you've been around a while, you've probably heard 1 CFM per pound per hour. That's kind of old thinking. Not a lot of dryer manufacturers subscribe to that at this point. And again, using more air costs you a lot of money. That number is typically rated as free airflow, which means if we take our dryer and we turn it on and we don't hook it to anything and we run it, those blowers typically produce about 1 CFM per pound per hour. But that's not how you actually run a dryer, right? You connect that dryer to a hopper. That hopper gets filled with pellets. That hopper gets connected back to the dryer. There's a filter, an aftercooler, and some type of desiccant media. And all of these things put back pressure on our blower. If you've ever seen a blower curve, you'll note that that changes the flow of the blower. So as we operate these dryers, they operate at 1/2 CFM per pound. So if you're comparing two dryers, it's important to note from the manufacturer, are they referring to free airflow or are they referring to connected airflow? Conair rates all of our systems based on connected airflow, which is how you, the user, actually utilize the equipment. So that's important to note. There could be some differences there. And time. Time required to dry this material varies based on the type of material. So it's not instantaneous. You can't put this stuff in and have it be done instantly. It's going to take time, referred to as residence time. Typically about 2 hours for non-hygroscopic materials, about 4 hours for our hygroscopic materials. The time to dry is going to be dictated by your hopper volume. Bigger hopper, more time. So if I asked you guys to go out and collect 2 buckets of material, I want 1 bucket to be filled with 10 pounds of rocks, and I want the other bucket to be filled with 10 pounds of feathers. Your box of rocks or your bucket of rocks is going to be a lot smaller than your bucket or your box for your feathers. It's important to note that here. So what we see often is that initially systems get sized for virgin material, maybe a little bit of regrind. And then 4, 5, 6 years later, the equipment's still running fine, but we start to introduce more regrind. What we're doing is we're introducing more of those feathers into our system, and we're impacting the drying time because now we need a bigger box to hold our lighter density material. So that's important to note. You can see how to calculate the volume up here in the right side. You can see that all of these variables have an impact. How much are you running? How long does it have to dry? And how dense is that material? And lastly, material hoppers should be mass flow. So if you've got an old surge bin laying around, it's not going to make for a good drying vessel. It's got to be mass flow, which means material's first in, first out. And there needs to be some way to diffuse the air through the system. If we have too little time, you're going to get insufficient drying, but also you can get insufficient exit temperature. So it's possible to dry material properly. Maybe it came out of the bag fairly dry, but you're drying not only to decrease moisture, but increase the temperature. Some molders like to do that so they get a higher temperature or a more consistent temperature into the feed throat. If you don't give it enough time, you might not have the right temperature. If you dry for too long, you could potentially over dry material. Probably a greater chance that you're going to thermally damage material than over dry it. But also capital cost. If you give it too much time, more than likely you've oversized the system and it costs you more upfront. And the last one is dew point. Dew point is probably the one that grabs all the headlines. This is the one that I think a lot of people think matter the most. With a lot of materials, it may actually matter the least of the four. There are some spec sheets that say anything lower than 0 degrees dew point can actually dry the material just fine. Why it gets so much notoriety is probably because it's shrouded in mystery. The other three quantities we can see. We can feel and temperature and airflow. We can see how big a hopper is. We can calculate a volume, but dew point's a little bit different. We typically gather it with instrumentation. So we'll try to pull back the curtains on that one a little bit. What is dew point? It's the dryness of the air. How dry is the air that we're passing over this material? Again, we get our low dew point air by passing our moist or wet air across a desiccant media. So think about it like the desiccant as being a filter for water almost. This low dew point air then surrounds the pellet and absorbs the molecules that are freed. We free those molecules with heat, right? And then water likes to migrate from areas of high concentration to areas of low concentration. So this low dew point environment is doing two things for us. It's giving us a very consistent and stable environment to dry our materials. We're not impacted by the environment. It doesn't matter where we put these dryers because what the pellets see is a consistently low dew point environment. The other thing that happens here is like anything in life, without getting too philosophical here, we want a balance. So we have a wet pellet and we have dry air. And those two things are going to try to reach some type of equilibrium. The moisture from inside the pellet wants to migrate to the dry air. This works in reverse when you have dry material outside of a drying hopper. If you have a moist environment, it's going to want to migrate this moisture into the dry pellet. So it's important to note what your environment is, and we'll get into that in a little bit more in detail later. Typically, material suppliers will specify -20 to -40 Fahrenheit to dry hygroscopic materials. Again, some are even stated at 0. Industry standard, a lot of people like to dry at -40 F. If the dew point is too low, more than likely you're probably just wasting energy to get to that point. We'll touch on that in a second. And if it's too high, high being less negative, so into the positive realm, we're going to get insufficient drying or inconsistent drying. So let's do a little moisture math. I know when I started here, when I started dealing with this stuff, it wasn't super clear what dew point was referring to. Dew point and relative humidity are not the same thing. Relative humidity is the humidity at a certain temperature. Dew point is a physical quantity of moisture in the air. So first and foremost, what you'll notice here is -40. That's our target for most resins. That's what most molders want. Why is it -40? Two reasons. As you can see over here, it's very dry air. What you'll also notice here is that it's the same temperature in Fahrenheit as it is in Celsius. So the difference between minus 39 and minus 40, or minus 40 and minus 45 is very low. It's very negligible. It's just a nice number that works for everybody. So let's use an example here. Let's say we have an 80-degree dew point. That means that air is holding 156 grains per pound of air. If we take that wet air and we dry it down to minus 40, we're now at 0.5 grains per pound of air. That's 99.6% reduction in moisture in that air. That's a huge difference, right? Every now and then you'll hear or see an ad, or someone will come talk to you, or someone will ask me for a dew point lower than minus 40. So they say I can do it at minus 80 or minus 100. Well, if minus 40 is good, minus 80 or minus 100 must be better. As far as the drying process is concerned, that's not really the case. We would call that diminishing returns. You're only actually losing an additional 0.35% of moisture. As far as the drying process is concerned, it's really not a big difference. So that's important to note. If you're getting minus 40-degree dew point, that is a great dew point for drying material. The way that Conair does it is we can actually hold that dew point. So we're not swinging between minus 100 and minus 40. We can hold minus 40, minus 20, 0, whatever you dial in, that's what you get. So it's important. Hopefully this helps you guys understand what dew point actually is. It is a physical quantity. So those were our 4 quantities, 4 fundamentals of drying. We control that here at Conair in our dryer. What you guys can do is control the initial moisture content. It does have an impact on drying. If your moisture content is higher, it can take longer to dry. So again, we touched on the material type, the ambient conditions, and exposure time all work together to tell you how much and how fast you can gain moisture in a material. In this particular nylon 6/6, nylon loves moisture. It can really gain high percentages of moisture. So in this example, let's say we opened our bag here at 0 hours. We were basically ready to mold this material almost right out of the bag. But then when we got the second shift, we find that they're not making good parts anymore. Well, there's a good chance that leaving this material exposed to this environment, 75% relative humidity, 23C, about 73 degrees Fahrenheit. If we leave that material out for 8 hours, we've gone from 2,000 parts per million almost up to 8,000 parts per million. So that material is going to have to dry for longer, or you're going to make parts with more wet material. So that is something that you guys, the molders, can control. It can be difficult, but when you're not using material, seal the bags. Only open the bags you know you're going to use. All of this stuff makes a big difference. We currently have a really good customer here at Conair. They're working on this. They're doing their own testing, and I think they found the same thing. Even in an air-conditioned environment, if you've given nylon enough time, it will gain enough moisture that it's very difficult to dry back down. Conversely, we're doing a similar test here at Conair with polycarbonate, and we've actually left material outside here in the Pittsburgh area for about a week, and we can't get it to gain any more moisture, which is what we would like for the testing we're trying to do. So it does depend on the material, it depends on the ambient conditions, and it depends on the exposure time. Down here I have another pro tip. It says dual blower dryers are more efficient and more consistent than single blower designs. So why is that? This is a schematic of the Conair dryer. We touched on this earlier, right? We've got one closed loop for drying the plastic and one open loop for squeezing out our sponge or regenerating our desiccant. The only moisture that we're asking this desiccant to take out is the moisture that comes off of the plastic. So it doesn't have to work quite as hard, and it gives you a very consistent drying environment. We don't care where this dryer's put, whether it's Alaska, Louisiana, Arizona, whether it's summer or winter, the dryer itself will operate the same. Here's a schematic of a single blower dryer. This one happens to have 2 desiccant beds. That doesn't have to be the case. This blower goes and it makes low dew point air for the process, just like the Conair dryer. However, because there's no separate system to wring out that desiccant sponge, it has to peel off about 20 to 25% of that air to regenerate the other desiccant bed. Where does that moisture go? It leaves the drying system. In order to make up for the air that the drying system has lost, it has to make it up from the room that it's in. What does that mean? It means that this dryer is coupled to the environment which it's used. Is it used in Louisiana? Is it used during summer? all of these things will have an impact on this dryer. A good example, we're all coming into summertime. We're going to turn our air conditioners on. Would you turn your air conditioner on and open all the windows? So again, it's another pro tip. If you are trying to compare different dryers, that's something to look out for. Is it a single blower or a dual blower system? Single blower dryers can dry material without a doubt, but they're probably going to cost you more money and maybe throw a little bit more inconsistency into the system. So now let's talk about drying systems. Again, they're not one size fits all. So let's talk about a couple different options and see what may be right for you guys here. We've got mobile dryers, machine mount dryers, central drying systems, and hybrid drying systems. Maybe it's a coincidence, I realized this after we made this slide. It's a honeycomb. Well, all Conair dryers use honeycomb desiccant wheels. So they don't have any clay binder that can break down. We don't have to heat up any extra clay binder. And they give you very consistent dew points, very consistent operating parameters, and a lot less moving parts. So it's one thing to note, all these dryers will work on the same principles. They're just going to be put together in a little bit different way. So the first one will be a machine mount dryer. This is the Conair micro wheel dryer. This one happens to be Medline, so it'll be great for medical molders, small throughputs, less than 20 pounds an hour. And this would bolt right to the machine throat, whether it's an extruder or an injection molding machine. The great part about machine mount dryers is there's no moisture regain. The material leaves the drying hopper, enters the machine throat. Same thing from a temperature loss standpoint. Very low temperature loss because we're going right out of the dryer, right into the machine throat. Machine mount dryers can be great from a redundancy standpoint. If you're a molder who has 10 different dryers or 10 different machines, each one can have its own dryer. So if you put one down for maintenance, the other machines continue to run. And limited floor space. In this example, everything is up off the floor. The control can actually be remoted down to the operator. In other cases, you could have machine mount dryers where the hopper is bolted to the throat, but the dryer sits on the floor. Or if you've got a mezzanine, you can put everything right over the machine and it would gravity feed the machine throat. All this stuff still pertains. A couple things to consider. This may require a step aid. If you got to get up and do maintenance or clean out this dryer, you may need some way to get up on the machine to do that clean out. You could have increased changeover times because you only have one dryer here, right? So if we've got blue material and we want to switch over to red material, we've got to drain the material. It's very easy. But then we've got to load it with our red material. If that red material is not already pre-dried offline or from the bag, we've got to wait for it to pre-dry before we can start our machine. So you could increase times between changeovers. So if you're someone who does changeovers regularly, something to consider. In cost per unit, that's not a good or a bad. These are very cost-effective dryers. However, if you're a molder who has 40 or 50 machines, you're going to want to weigh the pluses or minuses. There may be a different way to tackle that project. Mobile dryers. What we do here is we take that system that was bolted to the throat and we move it down onto the floor onto a cart that can be rolled around. Why? Great portability, awesome flexibility, even better redundancy. So again, if we've got 10 machines and they each have their own dryer, we've got built-in redundancy. But also, if we have a backup dryer, if we do need to do maintenance on something, we can pull the dryer out, move the backup dryer in place, and give ourselves almost no downtime. Fast changeovers for the same reason. So now instead of having to do full cleanouts to switch between blue and red, we can just wheel the blue dryer out and wheel a red dryer in. Very fast changeovers. If we don't have the ability to duplicate the system like that, these are very easy to clean. Everything is located on the ground. In Conair's sake, the hopper is actually raised up so you can drain it into a bucket. The doors are wide open, makes everything very easy to clean out. So these should be very quick to change between different colors or materials. The other nice thing is if you're just getting into this or you don't have a lot of infrastructure, you can actually have built-in conveying on a mobile dryer. Everything's controlled from the color touchscreen here, and these hoppers can actually load themselves and load the molding machine. They do that with closed loop dry air, so picking up additional moisture is not a problem. Some things to consider here. Typically, mobile dryers are only rated to about 200 pounds an hour. If you're someone who's doing 500, 600 pounds an hour, a mobile dryer is probably not a feasible option for you. They do require floor space. You're going to have some place either back in a room if you're doing this centrally or more often than not next to the machine. Cost per unit, again, not a good or a bad. They're very cost effective to implement into your system, but if you've got 40 or 50 machines, you're going to want to ask yourself if you want to duplicate that system 40 or 50 times. And typically one per machine. These can be set up to convey to multiple machines. They can support multiple machines, but typically they're one per machine. Here's a different way to look at a system. This would be central drying. So the way that a system like this would work is instead of one dryer and one hopper like we just looked at, we could have one dryer and multiple hoppers. There's two ways that people put these systems together. So if we don't want to have mobile dryers out on our floor, we want to consolidate the amount of equipment we got to worry about, we can still do a system that looks like one dryer and one hopper per machine, machines 1 through 10. It's maybe a little bit better because it's back in a room, easier to maintain, easier to clean, one dryer. That's one way to set up a system like this. And each individual hopper can have its own temperature. So this hopper could be at 300 degrees, this could be at 250 degrees, and this could be at 180 degrees. That's one way to set up a system like that. More often than not, however, what people do is instead of dedicating a hopper to a machine, they dedicate a hopper to a type of material or a color of material. So if we have 10 machines, maybe 3 of them run off of this type of material, 3 of them run off of this type of material, and the other 4 will run off of this type of material. What that does is it consolidates the amount of equipment that we need to do or need to purchase, and it limits the floor space of the system. If we want to change, if these lines here represent the feeds that go out to your molding machines or your extruders, to change over from one color, one type of material to another, all you have to do is move the line to a different place on the manifold, and you're already running a different material. So why do people do this? Less equipment, right? So instead of managing 40 individual dryers, we're managing just a couple large dryers. Very fast changeovers because, again, you can just move this hose or this wand over to a different position. You're ready to rock and roll. Easy to clean out. Everything's centrally located in some material handling room. The doors are wide open. You can drain into buckets. One dryer for multiple machines. And less maintenance. Again, instead of having 40 filters that we need to clean, we have one filter that we need to worry about cleaning. This also requires floor space, so that's a note. The initial cost. Some of this equipment is larger if you're planning for the future, which is a good idea. These systems can be added onto, but it's something you should take into account up front. And they do require provisions for conveying. So consider the last two options. They were both located next to the machine. In this case, this drying system could be 200, 300 feet away from our molding machines. We've dried the material. We want to make sure it gets to its destination dry as well. So we'll add things like purge valves, maybe dry air conveying. Those are things that we'll have to take into account on the Conair end, and we'll make sure we do that. And the last option was what I would consider a hybrid central drying solution. This is our multi-hopper cart called the MHC. It works just like the ResinWorks or the central drying system we looked at, but on a smaller, more portable level. So instead of purchasing 3 individual machine mount dryers or 3 individual portable dryers, we can purchase one smaller central dryer, and each one of these hoppers can control its own temperature. If you're a medical molder, if you're someone who does a lot of sampling, if you're a custom molder and you do a lot of changeovers, this could be a great option. It's a lot smaller footprint. It can be moved around. Again, portable, flexible, very quick changeovers. One dryer to multiple hoppers, so less maintenance. It does require some floor space, very good price point to initiate something like this, and it may or may not require some provisions for conveying, depending on how far away from the machine you are. This particular dryer I actually have available, so if this is of any use to anybody, I'd love to talk to you about it. And that is it. I am a fast talker, as you guys probably gathered. We'll open it up to questions. If you guys want to talk offline, without a doubt, go to conairgroup.com, call our 1-800 number. We are fully operational, making equipment every day up in Pennsylvania. So with that, Chad, I'll let you open it up to questions if we got any.
Sure, we do have a couple questions online. One of which was, is it possible to send material to Conair and then the material be tested to determine the best conditions to dry that material?
Yeah, right on. So we do have some, let's call them rules of thumb. So if it's a material that we've done before, we know a lot about, we may have that information, or it may be captured on your material spec sheet from your manufacturer. That being said, Conair does have a fully operational lab with testing equipment and drying equipment and blending equipment and everything you would need to run a system. So we do moisture analysis, so we can see how wet your material was before we dried it. And then we can do full-on moisture loss curves, so we can tell how your material dried, how long it will take, what temperatures to dry it at. That's all stuff that we do every day at Conair. We use a Carl Fisher moisture analyzer, which is the gold standard. Most other moisture analyzers are actually compared to a Carl Fisher titration type. So the results you get should be very good, very accurate lab quality results. And yeah, you can do that without a doubt.
Okay, we have another question about dew point monitors, and are they included with Conair dryers?
Cool. So dew point monitor is something we didn't necessarily touch on, but yeah, dew point monitors are always included on all Conair D series dryers, D and DX series dryers, which covers almost everything we make. It's a real dew point monitor. We don't calculate any values. We're actually reading the actual dew point of the air. If for some reason that dew point meter should fail, it'll fail and tell you it failed. It will say error or read some very big number. That's important to note because there are a lot of dew point meters in the industry that are a little, let's call them more price sensitive meters, and when they fail to tell you that the dryer is reading minus 40 degrees. So that's important to maybe do some spot checks of your existing equipment to make sure your dew point meter is being honest. But again, all Conair dryers do come with dew point monitors. Yeah.
Okay. How far can PET be conveyed from a dryer without additional equipment being needed?
Okay, cool question. So it depends on the application. So can you maintain dry PET? Without a doubt. You can convey it a couple hundred feet, let's say. It is important to purge that line. You may need to add dry air conveying, but the important thing there is temperature. Some applications, some machines will allow you to convey material to the machine and run it even though you've lost material. If you're someone who's running a packaging product, if you're using a Husky machine, it's important that you maintain a high temperature. So although you may convey this material to a machine over a long distance and maintain dry material, you may have lost too much temperature by the time you've gotten to that machine. In those cases, what we do is add touch-up dryers, not only to maintain dryness of the material, but to increase the temperature going into the machine throat. So I guess to reiterate that long answer is, it is possible to convey material, especially if you purge the line, up to 100 feet or more. The thing you'll want to watch out for is what happens when you get to the machine. You're going to want to minimize the amount of material that sits over that machine throat. So you can convey it there, but you don't want it to sit in a big hopper for an hour or two, because within minutes, PET can start to gain moisture. So that means use just-in-time type loading. So keep very small reserves of material over the machine throat and just convey more often.
Okay. And then a question about multi-hopper systems. How do you control the airflow in a system where there's multiple hoppers?
Right on. So maybe I can back up here, may help us out. So in a system like this, we've got the dryer, and the dryer makes the air, and each hopper controls its own temperature. What we do on a system like this is we have a balancing valve, and what that balancing valve does is maintain a pressure in the supply manifold, in the header that feeds all these hoppers. So underneath these hoppers, we have a supply manifold and we have a return manifold. And what that valve is there for is to maintain a certain pressure. At each hopper, there is an individual fixed orifice. And that orifice is sized based on the pressure that we're maintaining in the manifold. So because it's a fixed orifice and because it's a fixed inlet pressure, we get a fixed airflow into each one of these hoppers. So when this system was designed years ago, they did all those tests and calculations. So each one of these hoppers, if they're a different size, has a different size fixed orifice. What's important there is that that valve and that dryer work together to maintain that inlet pressure. Hopefully that helps answer that question.
That was great. What materials are inside the rotating drying wheel?
Gotcha.
So
So as far as
they're, go ahead.
no, go ahead. Is there any more to that, Chen?
They were just wondering if they have to change that out. How do they take it apart?
Cool. And usually I have a picture of that. I apologize, everyone. I don't have a picture of the guts here. But this wheel itself is a fiberglass substrate. Then the desiccant is bound to that substrate. So there's no clay binders or anything that hold our desiccant together. Most of our dryers, the smaller dryers, 400 and below, have a 5-year warranty, which includes the desiccant. It's not uncommon to see desiccant wheels last up to 10 years or more. The actual desiccant blend that we use is proprietary to Conair. But changing out a wheel is a thing you can do. We have a procedure, I guess if we want to get into that, I could send that. We can do that offline maybe. But it is also possible to wash these wheels. I can't say that always works, but there is a procedure that you can use to wash out a desiccant wheel should it be fouled up with some type of volatile or plasticizer over the years. So hopefully that answers it. There are desiccant wheels on the market that are paper-based. Ours is not. Ours is a fiberglass substrate. And desiccant, again, a proprietary mix of desiccant is bound to that fiberglass substrate.
Okay. We have another PET question. This one is, do you recommend or have you seen a daisy chain set of hoppers to help achieve the optimal ppm of PET regrind?
Yeah, I have. And if I understand that question properly, where I've actually done that before is on machines that have very broad throughput capabilities. So sometimes people will say, I have a machine and it can run 30 pounds an hour or it can run 170 pounds an hour. And so what we'll do occasionally is daisy chain those two hoppers together. If we do the low throughput, we'll use one hopper. If we do the full high max throughput, we'll use both hoppers. The important thing to note when you daisy chain these hoppers together, whether you're using one dryer or two individual dryers, is that you get the right airflow per pound of material. So what can be tempting is to say maybe I don't have enough headroom to fit in one hopper of the proper size, so I'm going to use two hoppers. The problem you get in there is that you're still running the full rate through each hopper. So if I'm doing 2,000 pounds an hour, I'm going to want 1,000 CFM per hopper to give me the right heat transfer into that material. What you can't do is do two 1,000 pound an hour dryers. You may actually have to upsize dryers to guarantee you're getting the right airflow. So that's just something to note. If you're going to split your system up, is that you're getting the right airflow in each hopper. The time would add up. So if you have a 50 cubic foot hopper and another 50 cubic foot hopper, that's equivalent to having one 100 cubic foot hopper. But you're going to have to be careful about how you use the dryers and how those dryers are sized for each of those hoppers. And again, that's a pretty particular question. I'd be very happy to go over that offline and dig into it with you.
Okay. We have a couple people who have asked how you calculate the airflow.
So you mean how we calculate the airflow that we're using or how we calculate the airflow that is needed? Anything specific there, Chad?
No, several people have asked, how can we calculate airflow?
Gotcha. So there's a couple different ways, right? So some of the dryers actually come with velocity probes that can actually calculate the airflow displayed on the screens. We do have packages that include those. Another way you could calculate an airflow, if you have an existing dryer, I don't want to get too engineering or too geeky here. But if you have a way to see the on-time percentage of that heater, you can use that to back calculate the airflow. Because power is going to equal the airflow times the change in temperature. If you know that you have air going into the heater at a certain temperature and leaving at a certain temperature, and you know the power of that heater, you can actually back calculate the airflow on each system. So you can do it with meters and equipment, or there is a way to calculate that. If you have the variables available to you, you can back calculate the airflow that way.
Great. Now this is an interesting question. Thinking about capital expenditure calculations and considering different type of systems, is there a difference in usable lifetime or lifespan between the different systems that should go into the expenditure calculation? For example, does a central system have a longer useful life than a mobile system?
Yeah, that's interesting. I've never actually been asked that question, but the answer I would say is no. They all have the same parts. They just get bigger as the size of the dryer gets bigger. So in most central drying systems, you're looking at a bigger dryer, but it's got the same guts that small dryers have. Again, we've got 2 blowers, we've got 2 heaters, and we've got a desiccant wheel. So to the question, I would say I don't have any data that says a big dryer lasts longer than a small dryer or vice versa. That is one benefit of the desiccant wheels is as long as they're protected, you guys change the filters regularly so we don't get a lot of dust that we don't want into the system. These can last years and years and years. In addition, at Conair today, we use what would be considered more like an open resistance type heater. So a lot like the hair dryer that you use when you get out of the shower. What we used to use were called tube heaters, and tube heaters didn't have a very good life, not a great lifespan. They required to be replaced a little bit more often. So now we use these open resistance heaters, and even those last quite a bit longer.
Okay. Question, is there any advantage to drying at a lower dew point below -40?
You know, I would say no. Let's see if we can backtrack to that one. Here we go. So let's look at -40 here on the screen. That has half a grain per pound of moisture. Again, think of a grain like a pound, like a kilogram. It's a weight. It's just a very small weight. We have half a gram of moisture for every pound of air. If we go down to -80, we have 0.03 grains per pound. So we haven't lost that much more from a weight standpoint. I've got half a pound weight, and now I've got less than 1/10 of a pound of weight. They're both very little. Consider the difference between where we started, in this case, an 80-degree dew point. We've dropped a tremendous amount of water. So if you look at this from a curve standpoint, it decreases at a decreasing rate. So you start to lose, as your dew point goes down, you start to lose more and more and more moisture. And then once you get to this point at about -40, it's diminishing returns. So I would say no, -40 is kind of the gold standard. Our dryers can hit lower than -40 if they need to, if they're fresh brand new wheels, but we wouldn't recommend it because it's just a waste of energy.
Okay. A question about blending and drying. If you're blending material with different temperatures, would you blend first or after the material is dried?
Oh, that's a tough one. We get that one a lot. So the drying process is going to be tethered to the more finicky or the more, call it fragile material. So if you have one material that dries at 300 degrees and one material that dries at 200 degrees, you're going to kind of be coupled to that 200 degree mark. Because if you go higher, you're going to start sticking it together or damaging it. So if there is a big disparity in drying temperatures, I would recommend drying them separately and then blending them together. If they're very similar, if they're similar in bulk density, if they're similar in drying parameters, then you could probably blend them together first. That would be my note. Ideally, everything could be dried last. Then you've got the best moisture content and you're coming out at the right temperature, but sometimes that's not feasible. So we do supply blenders that have dryer blankets and blenders that can handle high temperature. So if you have to dry two things separately and then put them into a blender, we can give you a dry environment to do that in.
Okay. And then we have kind of a combination question here. Why does Conair still stick with the desiccant wheel rather than tanks? And what's the life of a desiccant wheel?
Cool. So a couple reasons, right? So the desiccant wheel is very consistent. There's a lot less moving parts when you put that into a dryer. So from a user standpoint, it's a lot nicer setup, right? I think the best dryer that you have in your facility is the one you probably don't know you have. And what I find when I walk into a lot of these places, we ask them, how's the dryer running? And they're like, which one? Let's go check it out. Let's look at the screen, because they haven't had any issues. Less moving parts, less issues. The other thing is when you use desiccant tanks, most desiccant beads are bound in a clay binder. Over time of heating and cooling, that clay binder will actually break down. So not only does that mean that desiccant needs to be changed every so often, maybe every year, every 2 years, it also means that the breakdown of that material is putting some type of foreign object into your process. So think of it, if you're a medical molder, you're passing your air over dirt. For the Conair system, you're passing your air over a fiberglass substrate. So from a cleanliness standpoint, that's a big factor. Now, from an energy standpoint, 30% of that desiccant bead is the clay binder. So you're using energy and spending money to heat up dirt and cool dirt back down. So just consider that. We've had a lot of success with the desiccant wheel over the years. And if you average out the energy, right, so we give you a very consistent drying environment with the way that we do things. If you average that out with a twin tower dryer, they use a lot of energy a few times a day. We use a very little bit of energy all day. If you average it out, they're very similar from an energy usage capability. As far as the lifespan, again, I point a lot to our warranty on some of these things. So again, smaller dryers, 5-year warranty, which covers the desiccant. We feel very comfortable that those desiccant wheels are going to last that long. It's not uncommon to see desiccant wheels last 10 years or more. A big factor in how long a desiccant wheel lasts is going to be maintenance and protection things. So maintenance being, how often are you cleaning the filter? Do you guys have a good PM program? Are you guys occasionally checking the after-cooler coils? That's a big factor. The other factor is volatiles and plasticizers. So if you're using a lot of post-consumer materials, if you're making carpet and you've got a lot of regrind, even if it's a nylon material that's virgin, it can have volatiles or plasticizers in it. And if you know that, it's a good idea to put something we call a volatile trap into the dryer, because this volatile trap will help to condense those gases, and then they'll get caught on a mechanical filter. So anything that doesn't condense out on the water coils will get caught on a mechanical filtration system, and then that further extends the life of your desiccant wheel. If not, you could impregnate the wheel, and then you've got to do a little bit more to try to clean it out. So you'll know you have volatiles because when you change filters or you change desiccant, you'll feel almost like an oily film in a lot of your canisters or inside your hoses. And that's a good indication that you might have volatiles or plasticizers that are coming off of your material.
Okay. So we got some interesting questions here. One is, as certainly
I don't know
historically, since Conair has a long history of quality dryers, how do we feel about new technologies such as vacuum and infrared used in drying?
Right on. So let's start with infrared. So Conair does supply an infrared crystallizing dryer, if asked. It is not something we produce here in Pennsylvania. It is a buyout from another company who does this regularly. It is cool technology. It does work. Let's call it the issue with infrared drying. Very high capital cost. It requires a lot of floor space, not just for the equipment, but you've got to be able to remove the lamps and the bulbs. So you've got to have even more access area. The lamps and the bulbs can be expensive. So if if you're not careful and you break them, a little bit more from a maintenance standpoint. The other issue is In most cases, infrared dryers cannot achieve the final moisture content. They're just the first step in the process. So an infrared dryer can take something from wet to fairly dry, but in most cases, you still have to finish off in a traditional desiccant drying system to achieve a final moisture content. So it absolutely can be a good idea, but you do have to take all those factors into account. Vacuum is an interesting one. So I'd love to do another one of these here in a couple of weeks, and I think we will, and I'd love to touch on the vacuum dryer more. Industrial vacuum dryers have been around for a while, and on an industrial standpoint, I think there's some validity there. From a press side standpoint, I think there's a lot to be desired when it comes to vacuum drying. What we've found throughout our testing is that certain materials that are very easy to dry, like polycarbonates and ABSs, things that don't really require much of a desiccant environment to begin with, dry pretty well. Things like nylon, PET, PLA, things that are a little bit more difficult, a little bit more hygroscopic, do not dry well in a vacuum dryer. That's just what we found. In addition, we were working on a test right now, and what we found is the vacuum section may not be doing much at all. You may be actually looking more at a nice hot air drying system. So that's one thing I would note. If you're drying easy to use materials or easy to dry materials like polycarbonates or ABSs, it could be an option for you. If you're drying things like nylons, PET, you may struggle with vacuum drying technology. A good example might be the fact that press-side vacuum dryers have been around for about 18 years. They've not been copied and they've not taken off to this point. So I'll leave that one stand.
Okay. And then we have other questions here, but we're going to close out with one final question and then we'll close. The last question that we'd like to address is, when is an aftercooler required?
Sure, yeah, so let's get back to our diagram here. So aftercooler here. In Conair's case, these can be water-cooled or air-cooled. And the reason that those are there is to give us cold air before we enter this desiccant wheel. They are always included on a Conair dryer. Conair dryers can dry from 150 degrees to 375 degrees as standard. Most other dryers on the market can only dry from 180 to about 250 degrees as standard. Then they have to add an aftercooler. Ours comes this way as standard. So I come from a background of heat transfer, and the first question I asked when I started here at Conair is, why are we heating up all this air and then cooling it back down? Think about it this way. If heat drives off moisture from our desiccant, then the opposite should be true. If the air is colder, our desiccant is more efficient. So if this regeneration system is like wringing out a sponge, think about it. If you squeeze the sponge and dip your hand into a bucket of water and pull it back out, your sponge probably didn't gather that much moisture up. But if you open your fist and you dunk that same sponge in, it probably did. This aftercooler is the equivalent of letting our fist go and opening up that sponge so it can gather up more water. That's what we're doing here. Again, they're always included on a Conair dryer, which gives us a very broad temperature range that you can dry. If you've got to dry below 150 degrees, then we would add something called a pre-cooler into the system. That does come up from time to time, and we do have those available.
All right, thank you, AJ. For those of you who had additional questions, we will get to you offline, or feel free to email us at any point. You can use the Conair contact information. AJ, can you flip to that final slide again?
Sure.
Thank you.
There we go.
So you can use that Conair contact information on the screen if you have further questions. I certainly want to thank AJ and everyone in the audience for participating in this very informative event. The webinar was recorded and we will make it available at a later date. And we do have future education series webinars upcoming. If you want to mark your calendars, on May 8th, we will be discussing the challenges of ultra-low dosing and how to achieve accuracy. On May 22nd, the topic will be the benefits of temperature control units and how to choose a system. And the June 2nd Conair Education Series webinar topic is Understanding Blenders. Watch for more information on the homepage of our website, conairgroup.com, or on our LinkedIn page if you want to follow us on LinkedIn. And then if you'd like an invite, please email us at info@conairgroup.com. and request to be put on the email list for our Con Air Education Series webinars. Thank you all for attending, and have a great afternoon.